Earth feel simultaneously large and small. In some ways, it seems that humans are unique and unlike any other, and by extension, so is our world and our galaxy. And while recent astronomical discoveries have revealed that the Earth may not be as unique as we think, that doesn't mean that it's not valuable. Just as our shared experiences as people doesn't make our individual experiences any less valuable. So today, here at Unexplained Mysteries, we take a look at 3 recent discoveries. Galaxy systems match the Milky Way. Though the Milky Way is a special galaxy because it contains Earth and everything important to us, it's not actually one of a kind at all. Astronomers have discovered 2 faraway galaxies that are nearly identical to our own, with features that make them twins not just to each other, but to the Milky Way. While spiral galaxies similar to the Milky Way do exist and are quite common throughout the universe, these so-called twin galaxies have other key factors in common with our own. One example of this is that both galaxies have satellite galaxies similar to the Milky Way's small and large Magellanic Clouds. Only 3% of galaxies, like the Milky Way, have these Magellanic Clouds. Our own galaxy is positioned in what can be described as a cosmic dance between these large and small clouds. These clouds are clearly visible in the night sky from the southern hemisphere, and what adds to their uniqueness is the fact that the nearby Magellanic Clouds are a rare and short-lived incident in the grand scheme of the universe. They may no longer be present in a few billion years. So this occurrence of twin galaxies that also have these Magellanic Clouds is extremely rare. Aaron Robotham of the International Centre for Radio Astronomy Research at the University of St Andrews in Scotland noted in a statement that the total number of such galaxy systems comes to a total of 14, with these twin galaxies being the closest to an exact match. The twin galaxies were discovered while Robotham and his colleagues were looking through the Galaxy and Mass Assembly Survey. This database contains information on about 340,000 different galaxies in the local universe. The one thing they hadn't expected was to find galaxies identical to the Milky Way in such a detailed, specific way, which is very surprising. Such galaxies are very difficult to identify, that it hasn't been possible to do so until very recently. As Robotham said, everything had to come together at once. We needed telescopes good enough to detect not just galaxies, but their faint companions. We needed to look at large sections of the sky, and most of all, we needed to make sure no galaxies were missed in the survey. So much went into finding these twin galaxies, making it one of the most exciting discoveries for astronomers and researchers alike. The dark energy of our expanding universe. Sometimes we might take the night sky and all its wonders for granted, but while seeing stars and the moon and even the light of the planets may seem ordinary to us, the stars that you see in the sky each night are far, far away, and our ability to see them is truly a wonder. The mathematics that goes into calculating the distance of various stars to us is difficult, and it gets even more complicated due to the fact that the universe is constantly expanding. While a star that travels 100 light-years to reach our eyes is considered 100 light-years away from us, a star that travels 100 million years is way farther than 100 million years, and this is all because of the expansion of the universe. So the correlation of distance travelled is not the same as the actual distance of the star. It seems simple enough then to understand that if the universe was not expanding, then the distance would not be altered at all. Because each light is emitted with a specific energy and therefore a specific wavelength, it is to be expected that it would arrive to the Earth or our vision with a specific wavelength as well. However, because of the expansion of the universe, the wavelength of the light slowly stretches out as it travels from the star to the Earth. This change manifests as a cosmic redshift, and the amount that a distant cosmic source of light is redshifted also reveals the amount that the universe has expanded during the light's travel from its source. Using this information, scientists and astronomers can calculate just how much the universe has expanded by compiling a large quantity of these distances, their redshifts, then measuring either their actual versus apparent size or their actual versus apparent brightness. The way the universe expands is also dependent on its makeup, which means researchers can determine that too. What they discovered was that the universe is made up of 68% dark energy, 27% dark matter, 4.9% normal matter, which essentially means protons, neutrons, and electrons, 0.1% neutrinos and antineutrinos, and 0.008% photons. There is no curvature or cosmic strings, no domain walls or cosmic textures. Knowing this information has given researchers insight into how much the universe may expand in the future and at what rate. Applying these percentages to the law of gravity, by way of Einstein's general relativity, turned out to provide a lot of new information. The first surprising realization was that because of the universe's expansion, any galaxies not bound to us would eventually disappear from our view. Unbound by any gravitational force and pushed farther away from because of the movement of the universe, the space between those galaxies and ourselves just keeps increasing. Every second, about 20,000 stars move from out of our reach, meaning that we will no longer receive their light from this point forward, and they won't appear in our night sky either. Four images of a distant supernova. NASA's Hubble Space Telescope captures brilliant photographs, but very few of them are the same. For the first time ever, astronomers spotted a distant supernova split into four separate images, caused by the powerful gravitational forces of an elliptical galaxy that was found to be embedded in a massive cluster of galaxies. This observation is significant, as it will allow researchers to further refine their estimates surrounding the mass of dark matter in the lensing cluster of galaxies. The gravitational force emitted from the elliptical galaxy and the cluster of galaxies around it distort and magnify the image of the supernova, bending light and thus magnifying the object behind it in a manner first described by Einstein. The images are actually arranged around the galaxy in a cross-shaped pattern called an Einstein cross. While astronomers have previously spotted dozens of galaxies and quasars taken in multiple images, a stellar explosion has never been caught on several distinct images. It's believed that once these four images fade away, there will be a chance for astronomers to see the supernova again for themselves, as the current four-image pattern is only one aspect of the lenses. It's possible that the supernova appeared in a single image almost 2 decades ago, and it could likely reappear at least one more time in the next decade or so. The way that these images are captured by the Hubble Space Telescope is different than your average camera. While we can snap photos in a single second, one after the other, most of these images, and indeed the four images of the supernova, are usually captured within longer periods of time taken within days or even weeks of each other. This is because the distance and path that the light takes to reach the telescope varies depending on the surroundings between the source and its destination. The model of dark matter in the cluster allows scientists and researchers to estimate the distance and time it will take for the next image to appear, and they are gearing up to be prepared for when the next one comes. While the supernova of 20 years ago was missed, and these images were discovered after the supernova's explosion, researchers are hoping to catch the next one as soon as it appears, using their calculations to determine when that will be. The teams of researchers and astronomers spent weeks determining that what was captured in these four images was indeed from a supernova, the light of which was bent and refocused because of the dark matter in the galaxy and its surrounding cluster. If they are able to, however, they just might catch a glimpse of the supernova itself and be ready for it when it finally does reappear. But what do you make of these new discoveries? Be sure to let us know your thoughts in the comment section below and help us by growing this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.